today's date is May 20th. So just be glad next Monday you're not going to be here, and the following Monday we'll kind of, maybe it's 2 more Mondays. I don't remember. So energy transformations. These are flaps, and these are little flaps as well. I messed up underneath this one. This is actually my second take of this video. So I'm going to put paper underneath. So what is just describe the relationship between matter and energy? They are very much related. Energy affects the state of matter, affects the state of matter, which includes the atoms, particles that make up matter. So energy affects the state of matter, in other words, the atoms. Now, when we're talking about the states of matter, we're kind of talking about phase changes. Oh gosh, I love my arrows. Phase changes. All right, so in this case, we're thinking of evaporation to condensation. Oh, for crying out loud. What the heck? We'll just kind of just focus like that. Evaporation, condensation, melting. I don't know why I circled that one. Freezing. I'll circle all these. It's going to bother me now. And sublimation. These are either going to be kind of maybe adding thermal energy, so adding or reducing energy. So if you increase the thermal energy of water, let's say, it will evaporate. If you kind of reduce the thermal energy of, what was I going to say? Of the air, it will turn back to water. So it really is just a matter of adding and reducing energy. So they do have an inverse kind of relationship. They're kind of like best friends. Yeah. So there you go. Energy that affects the state. And now looking down here, I haven't messed this one up yet, so I'll have to have another piece of paper. Explain the energy transformations in each. So knowing that you have some basic understanding of the different forms, remember Mrs. Chen, okay. This is just something that one of my former colleagues I used to work with, this is how she taught it. And it's like, okay, it's kind of stupid, but it does help me remember. Mechanical, radiant, or light, sound, chemical, heat, or thermal, electrical, and nuclear. So this is just a good, easy way to remember the different forms. So if I'm thinking about the energy transformation in a fire, okay, I know it's not a propane fire, but even if it was propane, it's the same type of energy that wood is. Wood or anything else that's stored, we know it's a form of potential energy. So it's going to go from chemical, which is in the wood. I'll put that in parentheses underneath. All right, so the chemical in the wood to, so we're looking at it, the wood is burning, so we're going from a potential energy now definitely to chemical. It really doesn't matter which order you put this in, but it's going to be thermal, and heat would be an acceptable answer for the fire, obviously. And then also the light energy, light or radiant. Sometimes you'll see it written differently, meaning two different things, but in this case, radiant and light to me are exactly the same. Very, or close enough that I can call them the same and still know, and that is the fire as well. So the fire is giving off thermal energy and light energy. So transformations, it's just going from one to another. In this case, it's going PE to, whoopsies, don't put anything there, KE to KE as well. All right, so thermal and light are both forms of kinetic energy. Okay, so that one's a pretty easy one. Yeah. So there is that one. A car. Now, we are not going to assume that this is a regular gasoline-powered vehicle. And anytime we're starting off with the car, we are going to start off with chemical, another form of potential energy. And the chemical, because we're talking about the gasoline, even if it was diesel, it would still be chemical. Now, if it's a hybrid car, they still have fuel in them as well. Now, if it's 100% electric, you're still coming from a chemical form of energy, because even a electric car, like those things, Teslas, most of the time, power is still going to come from chemical energy. It's just going to take a couple extra steps in this case. If you plug your car in at, let's say, Harris Teeter, and it's a Tesla, it's still going to come most likely from a coal-burning power plant, which is chemical energy. So most of the time, even if it's not a a gasoline car, it's still having to come from potential energy. Now, unless you had like a car that when you plugged it in, its electricity came from like a water dam, or if it came from a wind turbine or solar panels, that's the only way it would not come from chemical. So we're looking at our little car. The car is chemical. Now there's lots of different routes you can take with this, because once the car turns on, I'm going to say electrical next, because there is lots of things going on.
All chorus students, please meet in the auditorium. All chorus students, please meet in the auditorium at this time. Thank you.
Okay, cool. So the gasoline to electrical, I'm just going to say the wiring, but this could go in a very different order, just depends, because we're thinking about the battery as well. I'm also going to say heat, because it's combustion that's going on. So we're going to say the engine. All right, combustion. What else can I say? I can say definitely, oopsies, KE, mechanical. Okay, in terms of the engine, again, is moving. The different parts. The car isn't necessarily moving. The engine is still on. Different stuff's going different places. So engine, and you can take this even further. If the lights are on, you're taking light energy. You can say sound, because the motor makes an engine, or the motor makes a noise. So all of that could be easily considered the energy transformation. So you can add more to these, but because of my little box, I'm not going to go too crazy. Now this little crazy kid, goodness gracious, look at all the energy he's got. Again, just like the other two, you have to start off with some form of chemical energy most of the time. That's not every time. It's not a guarantee. Oh, Miss Penny said that. But most of the time, you're going to start off with chemical. Oops. Chemical. Gosh, my desk is a mess. Chemical in the form of a person. This is why you need to eat. It's food. Okay, so he's not going to be able to really move without food. So when you're burning that energy, when you're exercising, when you're doing any sort of movement, it does require energy, which is why you die without food or sustenance. So this is going to be the potential energy that we're starting with. Again, not every transformation starts with potential energy, but for these three it does. So we have chemical, which is food, and this is going to go to mechanical. Yeah, we'll just say mechanical. The kicking motion. You can get very, very specific with this. You can say, well, his heart is pumping. He's breathing. Yes, all those would be mechanical as well. Don't want to take this any further. Is he doing anything else to it? He's just kicking it, right? So he's using his energy. He's kicking the ball. The ball is moving through the air, so it's still just mechanical. So I would just say this one is chemical and mechanical. Okay. Ta-da.